Today's objectives are to learn the prefixes of the metric system, what they stand for, and what their symbols are, as well as understand how to do conversions using the metric system. So going from a larger unit to a smaller unit or vice versa. Alright, next we're going to look at the metric prefixes. I have three columns here. We have the prefix column, the numerical value column, and the symbol or abbreviation column. Our first prefix is a kilo, which is 1,000, symbol lowercase k. Hecto is next, it means 100, lowercase h. Deca, think of a decade, its numerical value is 10, lowercase da. Our next one is blank because it changes depending whether we're looking at capacity, mass, or length. It's considered to be the standard unit, which equals 1. So each one of those is based on a standard unit, which is the numerical value of 1. Deci, like a decibel, 0.1 or 1/10, lowercase d. Centi, 0.01, lowercase c. And milli, 0.001 or 1/1000th, lowercase m. The first thing that we're going to take a look at is length. The basic unit of length in the metric system is meter, which is symbolized by a lowercase m. When we take a look at metric units of length, notice that the prefixes don't change. Alright, kilo, hecta, deca, deci, centi, and milli. The only thing that changes here is our standard unit for length, which is meter. So we plug that in, it's symbolized by a lowercase m, and it equals 1 meter. Mass is up next. The basic unit of mass in the metric system is a gram, lowercase g. Once again, the metric units don't change, but the standard unit is now gram, so it's a lowercase g and it equals 1 gram. Lastly, we're going to look at capacity. Liquid substances are measured in units of capacity in the metric system. The basic unit of capacity in the metric system is a liter. This is the only one that is symbolized by a capital letter, and it is a capital L. If we take a look at our metric units of capacity, the prefixes do not change. The standard unit for capacity is a capital L, and it's a liter. It is equal to 1 liter. Our next objective is to convert metric units. We're going to take a look at the stairs method in order to help us make conversions to metric units. If you take a look here, I put all the prefixes and their numerical values in these boxes, going from the highest one, kilo, to the smallest one, milli. Alright, this looks like a set of stairs, hence the reason why I named this the stairs method. There are three very simple rules in the stairs method. First, you have to determine your starting point. Second, count the number of jumps to your ending point. And third, move the decimal the same number of jumps in the same direction. So if we take a look at this example down here, 4 kilometers equals how many meters? The first thing that you need to do before we do the stairs method is convert the 4 into a decimal, which is very simple. You just add a decimal point and a 0 afterwards. Our first rule to the stairs method is to find a starting spot. Our starting spot is kilometers, which is right here. Now if you take a look at our ending point, which is our rule 2, figure out where that is and count the jumps. Our ending point is meters, which is our basic unit. Alright, our basic unit is a meter. So what we're doing is we're going from here down to meters. So let's count the jumps. There's 1, there's 2, there's 3 jumps. Alright, so what we're going to do is we're going to move the decimal point the same as the number of jumps. There's 1, there's 2, there's 3, and there's our new decimal point. Where there were jumps is now zeros, they are placeholders. So our answer to this problem is 4 kilometers equals 4,000 meters. Alright, our next practice problem is 1,234 grams equals how many kilometers? So the first thing that I'm going to do before I even get started with the stairs method is I'm going to convert this into a decimal point just by adding a 0.0 at the end. Okay, our first rule is to pick the starting point, and our starting point is right here. It's grams. Grams happens to be the basic unit of mass. Alright, and this is our starting point, so I'll just put a little X there. Our second rule is to count the jumps from the starting point to our ending point. Our ending point is kilometers. We could tell that because that's what we're trying to figure out. So we have 1, 2, 3 jumps. So our third rule is to take the decimal and move the same number of jumps, and then we're going to put a decimal point there. So if I go in here and I'm going to zoom in, our correct answer for 1,234 grams equals 1.234 kilograms. Alright, so let's zoom back out just real quick. Take this over. First thing you do is convert it into a decimal, which I did down here. Find your starting point, find your ending point, see how many jumps, 1, 2, 3. Come down here, find your decimal, take it the same way, same number of jumps, 1, 2, 3, to get your answer. Alright, our last metric conversion problem will be a capacity problem, since we already did a length and a mass problem. If we take a look down here, we have 0.075 liters equals how many milliliters? Alright, we already have it as a decimal, but just to give me some more room, we'll make it a little bit bigger here. Alright, liters is our basic unit of capacity, so we'll put that down here, and this will also be our starting point, so I'll put an X. Our ending point is milliliters because that's what we're converting it to. Let's see how many jumps we have. 1, 2, 3. So we have 3 jumps, which is rule number 2. We'll come to the decimal point, we'll count 1, 2, 3, and we'll make a new decimal point right there. Alright, so our answer is 0.075 liters equals 75 milliliters. Let me zoom out real quick. We'll just double check ourselves here. First thing we do is make it a decimal. It already is a decimal, so we're good. Find our starting point, liters, make a little X there. Rule 2, count the jumps, 1, 2, 3. Alright, go to the decimal, rule 3, do the jumps, same direction, 1, 2, 3. So our answer is 75 milliliters. Alright, so I hope you had a little bit of an understanding of what the prefixes of the metric system are. You might want to take some time, memorize them, because you're going to see them again on a quiz and probably on the test again. And we're going to run into the metric system units all year long in our labs. The second objective is to understand how to do conversions using the metric system. Hopefully the stairs method helped you learn how to convert metric units. Do practice it a little bit. It's going to help you out in the long run, and soon it will become second nature if you do enough practice problems. If you have any questions, like always, just bring them into class and we can go over them before we start our activity for the day.